In the movies, oncoming asteroids arise out of nowhere from the depths of space and rush right towards us until missiles or courageous actors destroy them. But in reality, asteroids follow elliptical orbits around the Sun. They're often discovered years, if not decades, before a probable impact, which is terrible for dramatic suspense but good for planetary survival. In 2021, NASA established that the space rock known as 99942 Apophis would not reach our planet for at least 100 years. This information was pretty soothing to humanity, as that specific apocalypse scenario was taken off our bucket list. However, NASA claims that in 2029, an asteroid the size of 3 football fields will approach closer to Earth than any other asteroid in recorded history. Is asteroid Apophis coming back? Stay tuned. Let's find out. Asteroid Apophis, also known as asteroid 99942, was founded by astronomers Roy A. Tucker, David J. Tholen, and Fabrizio Bernardi while working at Arizona's Kitt Peak National Observatory. The crew could only examine the new object for 2 days because of technological problems and adverse weather. However, more observations soon revealed a lot of information on the asteroid. Apophis is a near-Earth object thought to be around 1,100 feet broad. In 2005, the asteroid was given the Greek name Apophis after an Egyptian deity of chaos, as an homage to its terrifying potential. According to NASA, Apophis is categorized as a stony-type asteroid comprising various metals including nickel and iron. The asteroid is thought to have a long, two-lobed form, similar to a rocky space peanut. It gained popularity when astronomers learned that it had a 3% possibility of colliding with Earth in 2029, after analyzing its possible orbits. This potential danger could wreak significant damage to Earth if it struck. However, the team was well aware that Apophis would provide one of the essential opportunities for science to discover how the Earth came to be and how we could one day avert its destruction. Richard Binzel was a team member that measured Apophis's color characteristics and ascertained its composition using telescopic reconnaissance observations. According to Binzel, Apophis is a fragment of a planetesimal from the early solar system. It was more like a planetary building component that never formed into a planet in our solar system. The team discovered that the asteroid resembled the most prevalent kind of meteorite, called ordinary chondrites, mostly made of silicates and stone. It may be a piece of a bigger asteroid that broke away in a collision in the asteroid belt and has been conserved there for 4.6 billion years. The piece known as Apophis may have been sent on its present orbit, bringing it near to Earth due to the impact. The longer scientists follow an asteroid, the more distant its orbit becomes. Scientists could rule out the probability of 2029 hitting within a few months. They were able to rule out the even more remote possibility of a collision in 2036. However, future clashes could not be readily ruled out, particularly the asteroid's approach in 2068. Radar measurements showed that Apophis would not impact Earth when it passes by in 2068, giving us at least a century of peace. With humanity's survival ensured, at least from this peril, it was time to nerd out on some asteroid science. "We've never seen something that largely gets that close," said a JPL lead scientist Lance Benner. In the domain of space, close is a relative phrase. Apophis will pass around 19,000 miles above Earth's surface during its closest approach. That is around 1/10 of the distance to the Moon. Apophis will be visual to the naked eye from areas of Europe and Africa on the big night. In Los Angeles, skilled stargazers with binoculars may be able to glimpse it at about 3:30 a.m. The close asteroid contact provides an unprecedented opportunity to study its physical properties and to help us learn things that we've never been able to learn before, according to Benner. David Farnocchia, an astronomer at NASA's Jet Propulsion Laboratory who is researching the asteroid's trajectory, stated that the track of Apophis beyond 2029 would rely on how Earth's gravity alters the asteroid's orbit. The velocity of Apophis during the flyby in April 2029 may be precisely predicted because of the information gathered by scientists throughout the globe. He claims that an approach this close from a giant asteroid happens about every few thousand years. "It's something that rarely happens, and yet we get to catch it in our lifetime," Farnocchia said. "Normally, we send spacecraft out there to investigate asteroids. Nature is doing the flyby in this situation." According to the team's calculations, the asteroid's 2029 collision with Earth would cause its orbital period, or the amount of time it takes to circle the Sun, to increase from 1 to 1.5 years. More importantly, the CNEOS team was able to estimate how near Apophis would be to the gravitational keyholes that correspond to probable collisions with Earth in 2036 and 2068. The CNEOS team disregarded any possible consequences for the next 100 years. Because of the proximity, researchers can investigate Apophis using ground-based technologies never before used on an object of this size. OSIRIS-REx, a mission presently returning samples from the surface of the asteroid Bennu, will collide with Apophis in 2029. The ship, dubbed OSIRIS-Apophis Explorer or OSIRIS-APEX, will steer towards the asteroid until it's brought into its orbit, coming near enough to gather a sample from its surface. Hundreds of space pebbles collide with Earth every year, most of which are harmless. On the other hand, a large one might cause devastation well beyond its original impact location. Foreseeing the effects of an asteroid similar to Apophis striking Earth is complex. Nothing of this nature has ever been recorded in our planet's geological history. The dinosaur-killing asteroid that impacted Earth 66 million years ago and left the Chicxulub crater is only one example of a considerably more giant impactor. Other impactors have also been much smaller. The enormous Chicxulub asteroid, which collided with what is now Mexico's Yucatan Peninsula 66 million years ago, generated an estimated 420 zetajoules of energy. The world's aggregate power production in 2021 was around 0.5 zetajoules. The accompanying heat pulse melted rock and ignited flames throughout most of the world, followed by a years-long impact winter caused by a suffocating cloud of particulate matter blocking the light. By the end, 75% of species had vanished forever, including all non-avian dinosaurs. The amount of damage an asteroid impact may do also depends on the size, density, and mass of the asteroid, and the angle and speed at which it hits. Luckily, we now know that Apophis won't harm our planet anytime soon. Now that the prospect of an impact has been temporarily eliminated, scientists may concentrate on gathering data. Apophis researchers are preparing for the asteroid's passage in the years leading up to the second approach in 2029. They will watch from the ground. But now that a new mission for the asteroid sampling spacecraft OSIRIS-REx has been announced, they will also have the chance to see the event from orbit. Gathering information about Apophis might help scientists figure out how to redirect other potentially hazardous asteroids should they pose a danger to Earth in the future, since it seems comparable to around 80% of the PHA detected so far. If humanity needed to utilize that information to protect our planet from an asteroid collision, similar methods have been used to discover what is under the surfaces of the Moon, Mars, and Earth by sending seismic waves through these bodies. We have never measured the internal structure of a possibly dangerous asteroid. Perhaps Apophis will give us that opportunity. Scientists might be able to simulate the innards of the space rock for the first time thanks to observations of Apophis in 2029, which should also help them understand the asteroid's size, shape, and composition. NASA is developing a strategy to address this issue. It's the Double Asteroid Redirection Test, or DART. The DART spacecraft was manufactured and operated by Johns Hopkins APL, and NASA's Planetary Defense Coordination Office manages the DART mission as a part of the agency's Planetary Missions Program Office. The team continues to collect data from ground-based observations throughout the globe, as well as radar facilities at NASA's Jet Propulsion Laboratory's Goldstone Planetary Radar in California and the National Science Foundation's Green Bank Observatory in West Virginia. They are regularly upgrading the period measurement to increase its accuracy. The emphasis is now on determining momentum transfer efficiency from DART's 14,000 mph impact with its target. According to Nancy Chabot of the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, DART has given us some incredible data about both asteroid properties and the effectiveness of a kinetic impactor as a planetary defense technology. According to DART, the team is continuing to work on this affluent dataset to fully understand the first planetary defense test of asteroid deflection. We hope you enjoyed watching this video. If yes, we're sure you would like this next video here. Thanks for watching.